Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. I'm Chris. I'm going to voice over Arash's videos for the time being. Although Arash has got a mellifluous voice which makes many a species initiate their mating rituals whenever they hear it, he decided to delegate video voiceovers to me, because he wants to save his time for coding Primal Game Engine. With my help, he's able to spend considerably fewer hours editing these videos and has more time to develop the engine. I hope you'll find my voice as attractive, and besides, I'm pretty sure I've got a better humor. So without further ado, let's continue the series. In the previous video, we defined the high-level light API and started working on the low-level implementation. Today, we're going to continue and finish the code for directional lights. Then we'll be ready for sending the light data to the GPU for rendering. We can continue where we left in the lightSet class and write a couple of functions that will set and get various light properties. We'll start with intensity. Here we make sure that the intensity is not negative. We get a reference to the light owner and use it to get the data index for light data. If the light is directional, we update its intensity value. Again, we'll handle other light types later. We can duplicate this code for setting light color. Now we make sure that the color values are not negative. In addition, they shouldn't be greater than 1. Then we can update the color value in the same way. The getter function for is enabled simply returns the value that is held by the light owner. The values for intensity and color come from the light data, which we can get as before. The next functions are for getting the light type and the entity ID of the light. When we want to use directional lights for rendering, we need to tell the shader how many lights we put in the array. Therefore we need a function that counts the number of directional lights that are enabled. It loops through all non-colorable lights and counts the ones that are enabled. The next function will copy non-colorable light data to a buffer. We provide a pointer to a buffer of directional light parameters, and this function will just copy the light data to that location. It will only do so for the lights that are enabled. We'll only call this function to copy the data to GPU memory that's mapped to system memory, and we make sure that its size has the correct alignment. Next we loop through non-colorable lights. Because the data arrays are not tightly packed, we need to skip the slots that don't have valid data. Then we check if a light is enabled, and in that case we copy its data. We also make sure that the data index that's held by the owner is the same as our loop index. This is almost everything we need to write for directional lights in LightSet class. What remains for today is implementing these functions here. We can do this in exactly the same way as we did for the camera. That means that we can define function pointer types for setters and getters, and have two arrays that contain pointers to each set of functions. So we can again copy and paste from camera and modify it for lights. Now instead of referencing a camera, we refer to a light set. Therefore we need an extra parameter for light ID. Next we write functions that call the corresponding member functions in the light set, to get or set the values. Starting with isEnabled, we first cast the data to Boolean, and check if the data sizes agree. Then we call the enable function from LightSet and pass the Boolean. Now we can add this function to the list of function pointers. Similarly, we can write the functions for intensity and color and add those to the list as well. Note that we have more parameters than we have setter functions, and that's why we need to append a couple of dummy pointers in order to have the arrays be the same length. We need to repeat this for the getter functions. This time we cast the data pointer to the pointer type that goes with our parameter. In case of isEnabled, it's a pointer to a Boolean value. The value that's returned by LightSet isEnabled function is then written to that location. We do the same for color and intensity. We can add them to the array of function pointers. The last two functions are to get the light type and the entity ID, which we can write in the same way. Now we're ready to implement the low-level functions. These are all fairly simple. The create function just adds a new light to the light set using the light set key from light init info. If there isn't already a light set with that key, it will be created first, and then the light is added to the newly created light set. The remove function removes a light from the light set with that key. Note that if we provide a key that doesn't exist, a new light set will be created and we're going to get an error down the line when trying to remove a light that's obviously not in the new light set. So we might want to add some checks here later to make sure that a light set exists with this key. SetParameter and getParameter functions simply call the function pointers in the array of setter and getter functions, passing the parameter values. Okay, so now I'm getting an error that's rather cryptic, so I'm trying to figure out what is causing it. We're calling the bracket operator in FreeList, and because we are doing that in a constant function, it is calling the constant overload of the operator. In the assertion, it's calling this already removed function which is not constant, and obviously we can't call non-const functions from const functions. We can solve this easily by making already removed function const, since it doesn't modify any data. We can get rid of these warnings by returning a value for the case when light is not directional. Remember from last episode that if we'd like to be able to use STL vector, we can't call size in a constexpr function. So we need to do the same trick as we did before by creating a macro and use that one instead. This is all we need for now for managing directional light data. Let's add a new file in Engine Test Project where we can write some code to generate lights for testing. I'll define two keys for testing with multiple light sets. We'll need an array to hold the lights, so we can refer to them and remove them later. Let's have a new function for generating lights. Here we can fill in a light init info for each light and use it to create a couple of directional lights. Because we need to create a game entity for each light, I'm going to call the functions for creating and removing game entities that we have in testrenderer.cpp. Therefore we need to forward declare them here. Actually, before we do this, let me improve our entity creation function a bit, so that we're able to attach arbitrary entity scripts to game entities. We can simply pass the name of the script, and our function here will use that name to get the script creator function. Now we can create entities with or without scripts. For now, let's create our lights without any scripts attached. The light type is directional and we're adding these to the left light set. In order to make it easier to set colors using RGB values, I'm going to write a function that converts the byte values which are between 0 and 255 to floating point values in a range of 0 to 1. Now let's create 3 lights with different colors. The second light shines from above and the third light shines from below. This is to simulate sky light and light that's reflected from the ground, similar to what we did for our WPF geometry viewer. Let's update the calls to create one game entity function next. Running the test application succeeds without any errors. Just to test the light sets, I'll add a few more lights to the second light set. Finally, we need to write a function that removes all lights. Here we loop through all lights, get the entity ID from each light before removing it, and remove the game entity using that ID. At the end, we clear the array of lights. In testrenderer.cpp, we call generateLights function at initialization, and removeLights function when shutting down. Of course we need to forward declare these functions so that we can call them in our code. I'm happy to see that we're still able to run the application without getting any errors. That means that hopefully we didn't make any mistakes while writing our lighting code. We can only be sure, however, when we actually use these lights to render our scene. So that's what we're going to try to do in the next episode. As always, thank you so much for joining me today, and I hope to see you next time. Hey Arash, sup?
Hey Chris, how did it go?
Hey man, I just finished the voiceover. I tried not to laugh at my own jokes, hahaha.
Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering.